So we have just listing of the major differences is the oil spill modeling. We've had a major upgrade of all of our boundary condition forms and improved a lot of functionality. We've added a brand new boundary condition type called a low chord boundary, which I'll likely demonstrate here in a little bit. Under the view plan or the 2D plan view, we can now extract time series contours, we can do filtering, mean mass transport for fields, add velocity roses, just many, many features. This is just one page. Second page, continued, we can export shape files with water quality constituents now defined, model rotation, which I'll demonstrate. Nice feature now, let's say the model's running, you lose power, the model crashes because you don't have any power, you come back in, you can restart it and then merge the two outputs with EE, but you can also now just have a continuation run. You can just tell EE to start up and it'll just start from the last restart file and just keep writing all your output files. Model analysis, we have this new cruise plot capability. Windrows, you can automatically generate windrows inside of EE, and we can handle multiple stations, automatically setting up the weighting for multiple atmospheric and wind stations. More, I know, exactly, that's the problem. There's so many new features. Base date, so you know that base date that links the model Julian times to a calendar date. You can now change the base date and it will automatically update all your time series files if you want it to. So it's a nice way to just be able to change all your model timing quickly. Triangular cells, EFDC has the ability to handle edge cells that are triangular, and now EE supports that and has some nice automated features. Velocity 3D velocity banners, enhanced blanking and clipping of our 3Ds images, viewing the oil spill options. These are all a range of the different options that have now been added to 7.2.
3页新功能好不好？就是这样，它的惊喜，那个非常多的惊喜。刚才还有一个，比如说这里有个 restart， 在后面我们后面那位学吉他的这个同志肯定刚才也非常一个兴奋，他老是说自己的这个电脑这个单位容易断，这个东西断电是不是？那个断电这个东西就可以解决你的这个功能啊，解决你这个问题。然后还有很多一些那个前处理后处理啊，网格啊，这些东西，它这个可以处理那个3角形的网格，待会儿我们可以让它展示一下，就是到底是他自己画还是那个他那个就是可以从别人模型里面引进这个3角形网格，因为现在还不能从别人模型去引入3角形网格。OK。
So this is a couple of snapshots of some new features. This is an analysis showing the cruise plots. Let's say this is San Francisco Bay, and let's say this is actually a cruise that the USGS performs, I think, twice a week or twice monthly. I forgot which it is exactly, but they run from the South Bay up through the straight into San Pablo Bay and on up into the Sacramento River. And they do that, and of course it takes about a little over a day, 12 hours to make this full run. And historically there wasn't an easy way in EFTC to compare, or EFTC Explorer to compare this type of data to model results. Now, this is an example of an output directly from EE. The top panel represents the data. 0 is the starting point of the cruise as they went, so it's matching space and time and then contouring the information. So this is your data panel up here. This is your model results compared down here. And then we have the ability to put markers in, so it gives you a spatial reference. So this is a new feature.
这个的话讲的是一个就是类似于他用了一个很形象字啊，这个一个 cruise 啊，一个形象的意思。就是它这个什么呢？就是它画了一条线，它可以对比这个就是这样。就现在我还没有见过这种这个两个断面在这个垂向和纵向的这个画图进行这个对比，是同时画在一张图上面。它这个东西它现在已经做了，这个应该是说一个比较好的后处理。 就是这个的话是一个实测的 USGS 的话，一个实测的一个垂向和纵向的一个圆度的一个空间分布，还有这个的话就是模型的模拟的一个分布。它可以的话可以将你的这个空间上的话的那个，还有这个空间上这个垂向和那个纵向的那个断面的话弄在一起，然后呢这样可以进行一个对比。Can we do the statistics?
Yes, actually.
The cruise plot. Okay.
Yep, the statistics will also be presented or prepared and available for each cruise plot.
OK. 就它这个除了这样一个那个展示的这样一个图之外，它还这个跟刚才我们之前一样，用那种咱们的这个误差的经常的相对均方跟误差呀，这些误差指标，就对这种这个 cruise plot comparison 就进行了这个就是实际数值上的这样一个对比。这样的话，到时候我们我们除了展示，我们还可以写在报告里，对不对？
A new feature is whenever you generate any kind of time series or really any kind of line plot, you have available to you the ability to generate low pass and high pass filter analysis of the data. And so that if, for instance, in this case, you had some series that had some sinusoidal, signal in there, and you wanted to look at filtering it out, you can apply a 12-hour filter, and this is totally user specified, and EE would provide that line to you and as a separate line or only show the filtered line, and you can do this ad hoc, or you can actually build it right into your calibration statistics and plots. So if you've got a year-long simulation and you have a harmonic, you have tides in that period, all you can see is just a big thick blob, but you apply a filter into it and you can see the underlying signal to the data. So it's a very nice analysis, robust feature.
这个的话讲的是这个就是一个滤波的功能。这个滤波之后，滤波上滤了什么信息的话，有没有人那个帮我解释一下？有没有人帮我解释一下？后面那位北大的同学能解释一下？
它就是等同于一个时间序列，我们有点类似于时间序列分析。
对，时间序列分析，但是它滤波滤出来什么功能？因为它这两条线肯定是它表述的是一个信息。
对，它比如说像时间序列，它会有那什么周期项、残差项、季节项、什么趋势项、季节项、残差项嘛。我觉得它这边是把残差给滤掉了，然后得到了一个周期，同时还有一个趋势的那个。
对，一个趋势这样感觉，就是说，比如说我们得到的一个这样的一个数，它可能是一个正确的波浪形，然后呢，但是波浪形的话，我们看不清楚它的一个趋势嘛，它就可以将这个波里面的一个信息，比如说一些残差信息给滤掉。我们的滤波有很多种滤波方式，这个就不做解释。然后呢，在滤掉这信息之后呢，就可以得到一个比较稳定的一个趋势，这样可以看到一条黄色的线，这样一个趋势，得到这样的信息。这个信息的话呢，可以用来做这些滤定，因为我们监测不出这种正确的信息，只有我们模拟不出这种波的信息，所以我们把它模拟出来波的信息里面可以去掉这些残差项，可以得出这样一个黄色的这样线，然后可以用于这个预定验证啊等等，这样一个就是很好的一个这样的分析工具。OK。
Another powerful feature, especially for systems that are tidally influenced, is the residual field or mean mass transport, where you can specify, the user just specifies the period of time in which EE will go out and average whatever the 2D field is that you're looking at. It could be velocities or any of the scalar variables available in water quality. In this case, we're averaging magnitude. But this feature is that way you can kind of look at your tidally average signal of really what's going on in an estuary, for instance.
这个的话也是就是一个平面展示的一个功能，这个也是可以展示你的所有的这样的一个数据，它是一个就是物质运移的这样一个平面展示。OK。
We have a lot of windrows and velocity plot options, and I'll show a few of those later, but you can now quickly get windrows directly out of EE for reporting and just for analysis purposes.
这种图的话，就是可能更加适合于画那些什么雷达、风向啊，就是这种带有角度和方向这样一个矢量的这样一个图。这个的话就是很多画图软件，什么 R 啊，还有什么graph 呀，还有等等这些东西，就是 grapher， 就是这些东西的话，它可以画这种叫什么图来着？对，枫玫瑰图啊，主要就是这种图。然后呢，它这个 ELDC 里面也可以给你的这种数据比如流速啊这种矢量图，也可以给你画上去。OK。
For as an example, this is the Sydney Harbor model, and we extracted the velocities from a location for a period of time, at this location, and EE will, you just click on it and generate a rows. You can click on another point and generate a rows, and then this is a single plot you can output. So it gives you a good summary, both a spatial analysis and a temporal analysis associated with your velocity patterns all at once.
这个的话，然后就加上你的这样一个连接区域的话，你可以在比如说你关键的一些断面，你可以把这个断面的这个流速和这个流向都可以用这样一个这个图来表示。那么你加上它空间信息的话，就更直观一些。OK。
If you're doing a lot of connections of grids, subgrids, if you have subdomains and you're connecting one subdomain to another, this tool here is real nice where you can just select or build a polygon that will automatically connect two subgrids together based on the best matches on their faces to north to south. So that's a real huge time saver if you've got big grids.
这个的话可以实现一个网格的拼接，就是如果你就是比如说这块的话，你想那个更加精细化的模拟，这一块你想粗糙化的模拟，比如说这块可能是红泛区，这块是河道以内，那么的话，你可以将这两个网格的这个不同的进行划分，划分之后的话，你可以画一个这样的 polygon 的话就是一个多边形，画个多边形用这种那个 NS 就是 North and South Connection Right， 就是这个南北，就是它这个南北的意思其实也是个形象化的说明，也就是说它可以各个方向都可以连接。然后呢，它可以画这个，画了这个，像这个跟打补丁一样缝起来，然后缝起来之后，它这两个网格可以拼接起来了。OK。
We now support triangular cells on the borders, and you can edit and change them inside the modify cell feature.
这个的话就是在那个二维的这个平面里面的话，你就可以将那个边界的一些网格，因为刚才我们看那个二维那个湖泊的图，它边界的地方也是一个矩形网格，有的那个矩形它会超出了那个湖泊的这个边界，这个的话呢，就相当于是让你的这样的边界的话呢，更加适应于这个按坡的这样一个这个不规则的图形状。OK。
With that, what I'll do here is I'll bring over the 7.2 example here. So let me just close boundary condition here. And close out 7.1 so I don't confuse myself, which I already did. So there we go. 7.2. So it looks very similar, but some of the significant changes, are the cruise plot addition here, and what you can do with linking model to data again just continues to improve in EFBC Explorer. So if we come in here now to the 2D plan view, and I want to look at velocities, eventually it'll come back. There we go. Zoom in down here, and let's say I want to generate a velocity rose. I just right mouse click on the cell, and I can get a velocity rose. And I can pick the time I want to extract, which I don't want to extract that long because it'll take too long. So let's just pick a period here. About 2 days. Should extract fairly quickly. And so this provides the quick summary of the velocity plot at that location.
就这个的话，就是说它可以在那个模拟一个就是把这个网格上的流速，这2天的流速给画在这样一个维格图上面。
I can change all the scales, sectors, all the formatting. A lot of format control is available to you. And one of the things I can export and I can show on the plan view. And then this thing closes out. There's the little pointer, and it shows you what cell that it's connected to. And then as you zoom around, and you can bring in multiple cells, and I'll show them on the same plot.
So if we turn on the animation, will this the rows map?
The rows map does not animate because it's an average period
okay.
for the specified period.
For the 2 days, right? Average for the 2 days, right?
Well, right. For the 2 days I extracted.
他说这个就是那个这样的话，这个图就可以在这个 domain 里面也显示，就是刚才是在就刚才我们就是加上空间这样一个坐标，它这样在右上角的话，它会连接到你这个网格。 这个图的话，它用的是一个平均值，所以它那个一个最大最小一个平均值。然后如果你自己将这个用动物做动画的话，它这个后面的这个 domain 里面的这个流速会动，然后这里不会动，因为这里是平均值。
Okay. So another major upgrade in EE is our boundary condition editors, and what we've got here is a lot of different kinds of boundary groups. We have open boundaries in this model. We've got flow boundaries. We have withdrawal return boundaries. We have hydraulic structure boundaries. So if I want to come in here and look at one of these boundaries, for instance, let me go back out and kind of pick up, say, maybe one of these boundary groups up here. Turn on edit, which I can't do, and press on the 0. And zoom in close enough, I can select the cell. There we go. That's what I had to edit. So this is the new form, and every form has been redesigned, but you'll notice now, for instance, instead of just having to put in a number, that ID that you've associated with your series is now available to you here, so you can clearly see whether or not.
Which series, right?
Well, right, which series you're linking, whatever temperature series you're linking to this current group.
Okay, 就是它这个比如说这个编译条件嘛，它这个有一个新的功能。首先看着这个编译条件这个框大了很多，然后那个大了它下面这个地方的话，它有一个这个咱们不是经常要把这个盐度、温度、水质的序列要对应到那个流量的序列。它对应的流量序列，我刚刚说了，就是说第一个就表示第一个序列，第二个第二个序列。这个的话就可以看见你的那个到底是对应哪个序列。你可以，这就是我说命名比较重要，就是命名成相同的名字，这样的话到时候对应起来比较好对应。OK。
So every form has been customized for the particular boundary group that it is. So over here on the open boundaries, similar linkage to the tables, but because every boundary condition has its own unique set of characteristics, we've just made the whole form more robust and complete in the ability to control and manage these boundaries.
它这个它就是说它就在这个编译条件这个界面的话，它希望这个编译条件更加完备、更加人性化、更加就是更加强大 ，robust， 它特别喜欢用这个词。
Okay. Now with that, let's just look at another example here. Okeechobee real quickly. Now this one just has a quick demonstration of your edge cells. So for instance, let's say you have a lake and you have set up a grid, but you really the shoreline isn't jagged like that. It's smoother, and you've set up the grid to follow it a little bit better. You now have the ability to you can create your grid originally in the quadrilateral, and then at any time you want, you can switch it to a staggered grid, and it'll automatically go out and add your triangular cells at your borders. And then if you don't like one particular border or another, you can just go in and edit it manually.
OK， 他说这个网格，你看它其实是做了一个削减，它其实是根据它的边界做了一个削减，将边界的网格都用三角化处理了。其实它这个也没有说什么基于用了一个非结构性网格，它只是将这个边界的地方用三角化处理，填补了网格与边界的这样一个空白而已。
Oh, let's actually let's load up the other one here. Let's go run. We need output to do this. Let's not do that one right now. Let's look at low chord. This is a new boundary condition in EFDC, and the concept is bring up a 3D view of it. This is a very simplified example using a trapezoidal channel But the idea is that you have a bridge, and the bridge, as long as the water is flowing in the river or stream below the bridge, it's full hydrodynamics are in effect. But once the flow reaches the low chord of that bridge, a new hydraulic regime is established. And if you have a rating curve for that hydraulic regime for the bridge, you can put that rating curve into EFDC, and EFDC will handle that condition now within a simulation period. So I'm going to go in here and real quickly change this to solid color and gradient for the surface. Turn on lighting so you can see the trapezoidal color a little bit better. And then at this elevation here, this bridge or this line here represents roughly the elevation of the low chord. So as I step out here in time, oops, not that, go to I can, now I'll just have to step in here. Here we go. So as the water levels increase, water's just flowing underneath the bridge just fine. And then as I step forward in time, I have a tide signal coming in from below, but I begin to, the flood peak level coming in at the upstream boundary here begins to impact the bridge, and I start having overtopping of the bridge, and you can actually see a step in the water surface elevation due to the effect of the bridge here now. So so you can have bidirectional flow underneath the bridge most of the time, but then when you get to this low chord effect, the hydraulic structure takes over inside the model.
他说这个就是这个地方加了如果有一个桥，这个桥的话，如果水面没有越过这个桥的话呢，它是一个有原来的 EFDC 这个全部完成水动力这个过程。如果它这个水面越过这个桥的话呢，那么它这个水动力过程就要进行改变。Does the hydrodynamic equation change if the water?
Yeah, well, once the water reaches the low chord, what EFDC is doing is it inserts a hydraulic structure boundary condition, and the boundary condition hydraulics begin to dominate, or they take over the cell dynamics at that point in time. Before then, full hydrodynamics are in effect.
它是那个在边界条件的情况下，它它将它这个方程没有变，但是它在边界条件里面，它识别了这样一个中间有一个insect 插进去的这样一个桥。在这个情况下是一个横向的，就是垂向的话，我们经常也能见到，比如说我们经常一个桥的有一个柱子，对不对？然后桥底下桥柱子，这个的话，我们经常是就是说也设一个过流的网格就可以了。然后呢，但是这种横的话呢，就我们没有了，一个新码功能的话，就加入了这样一个功能。然后呢，当它这个水流它小于这个桥的这个底部的位置的时候呢，它是一个全部水动力过程。如果它越过这个水动力位置上，它边界条件会启动这样一个边界条件，那么它的边界就会影响它的流场。这个的话呢，就是可以在中国的话就很好做，就是有很大的应用前景。就比如说我们做那种这个建桥的时候，水面淹没损失啊，都是这种东西的话是比较好的东西，对不对？
If this model had been running and had crashed, and I had a restart file available, this continuation button would have been enabled, and all you got to do is click on the continuation button, and then basically hit start, and the model will, we have to save it, but then EFDC will just continue from the last restart file automatically.
So the continue button will not be available until it was collapsed.
Well, no, it has to see what EDE is doing here is it's making sure that there is a valid restart file, restart.out that exists from the current run. And if it does, it allows you to just continue a restart from that, or continuation from that point.
Okay. 就是它这个你要看它这个地方你的模型上开始有没有构建这个 restart 就是这个热启动的这样一个文件 restart 点 out 如果是有这样一个文件，那么它那个模型这个continue 的地方就会变白，你就可以点。如果没有这个文件，也不能启动，明白吗？就是在你的这里的做的那个过程中，你必须得，你比如说你可能担心这个地方你算错了啊，那你先将这个热启动开启。这个会减慢一定的速度，但是也没有关系。这个为了你的安全性，你也可以，你要越级的值的，你可以一试，然后点到就生成这样一个 out 文件。这样的话，到时候一旦出现断电啊，那就或者是出现什么样的情况，或者模型崩溃，你就再重新从那个地方去算，它会自动开始识别那个点。OK.
Okay. So let's say we've got another case here. Well, actually, we'll do it in this one. This is the Apalachicola Bay, and let's say actually I prefer the orientation for the plotting for this to be a north-south printing. My grid, this is correct with respect to the grid. I'll bring up the north arrow here and show you what I'm referring to. So, the grid north is that direction. But if I want to rotate the grid, I can put an angle in, and the whole grid is rotated for display purposes, just for display. So it just helps you orient the model domain to your printing space or whatever it is that you're trying to work in without having to do it manually. And that way it can be consistent from plot to plot to plot.
Okay. 他说这个功能的话呢，并不是将你这个整个区域的这个坐标颠倒，而是将你这个展示在这样一个二维的图里面的颠倒。颠倒的话，目的的作用呢，是为了让你这个二维展示图更好的有一个空间的布置，还有这样你也可以免除你让你的这个，因为比如说你的手动去让它旋转，你不一定能旋转的那么好啊，所以它这样给了一个准确的角度，你可以选任意的角度。然后呢，这样的话呢，你来输出图的时候，你可以有不同的角度，你可以输出不同的这个图，你可以说从这个角度看是这个样子，比如说它这个有不同的展示功能。OK.
Yeah. So let me stress the model coordinates. Nothing's changed as far as the actual application. It's just the display. Okay. Now another feature here that I want to demonstrate is the new velocity banner capability. So traditionally, when you're trying to display velocities in 2D and 3D, it gets quite busy, quite fast. It's difficult to interpret. So especially if I turn on an animation here, come on down, I don't want to move today. Stubborn. So if I turn on an animation, you can watch the vectors move in and out. This is an inlet right here, and there's another inlet down here, and there's islands that exist all along the edges over here, so there's no flow at these boundaries. But very difficult to interpret this kind of result because there's too much going on. So what we've done is we've generated some new features for looking at your velocity. And what we're talking about here is a velocity banner. And the concept here is that one just does not want to move. So I'm just going to hide it. I'll hide that frame so that it doesn't want to move for some reason or another. There we go. Stubborn. So what I want to do is, it's like a flag. So as the velocities are moving and changing with time, it's like this banner or this flag is flying around. So I'll just look here. If I want to do it on say a 3x3 and change my velocity scale, I can now see how the banner is changing, and I can change the color of the banner by depth so you can see it a little clearer. Let me just turn on the solid color for once the light's on, then you can see, and again, it's kind of a flat bottom, you can see a little bit better. And then, turn on more vertical exaggeration. In this case, I'll just raise it up to like 15, so you can see things a little clearer, and then turn on the animation. You'll be able to interpret it just because the banners are connected. Your eyes are drawn to your brain. It just interprets this data a little bit easier as you're looking at all that information moving around. So you can see the tide going in and out. You can see, this is a deep channel on the back side here, bringing in freshwater flow down this channel, and you can see a real strong flow divergence, at the different depths based on the tide and density signals being applied and wind signals. So this is just a new velocity viewing option in the ESCC Explorer 7.2.
对，它这个模型的话，它这个地方的话呢，就是一个 banner 这样功能，就是在流速这块，它可以选择一个这个 banner 功能的话呢，可以就是让这个流速它不是一个以箭头的形式来展示，而是以这种像一个红旗一样，就像一个旗子一样的这个形式来展示。它的这个颜色就是和它的这个长短的话，都可以分别代表它的这个流速的大小。从上到下的这样一个这个颜色的分布，你看它是水样的分布。它刚才的话也是做了一个这个简化，就是将2个网格或者3个网格中出现一个这样的旗子。那么这样的旗子的话，就可以相当于是你可以观察到就是这样，就是这样一个网格，这个网格它这个流速的话，它是往哪个方向走，它是它的这个大小是多少，然后垂向是个什么样的分布，然后整个domain整个研究区域里面的话，流速是什么样的分布，都可以一个动态的一个展示。OK。
JetBlue. Let's look at the new functionality there. Okay. This will be the last thing that we look at today. We can look at this more tomorrow if we have time. So the plan. Port diffusers. So this is the example that we were looking at. Oh, I didn't mean to do the 3D. This is the example we were looking at yesterday.
这个就是说，刚才就是昨天我们南科院的2位老师也解释了，就是一个射流的过程。一个射流，它比我们的一般的这样一个入流要更加特殊。然后它 ELTD Explorer 它就在这2个地方它就有一个射流，它模拟的这样射流的温度和其他一些物质的这样一个运行过程。OK。
Actually, this one's a JetBlue, but this one's more of the output. Actually, what I meant to load up is the Novato, because it has the hydraulic structures I want to show. So that's here. This particular model had a number of, well, it is 3D, but for the purposes right now for visualization, we'll just show the. So we have a diked system through here in large areas of lowland agricultural land, and there's all these hydraulic structures controlling flow between some of these different diked areas, and then outlets from a diked area into the river. And these are all hydraulic structures with rating curves that are downstream dependent flow conditions.
就是它这个图上面有很多控制流量的这样一个建筑物，不同类型的叫水工建筑物。
Okay, so I go in here to boundary conditions and look in here and edit. So this is the new hydraulic structure boundary condition. It's a much more robust capability. We now have, this is where you set your type of hydraulic structure flow conditions, whether or not it's by upstream depth, elevation difference with flow acceleration, or just upstream, downstream elevations, or this is where you define the low chord options. Then, based on your settings here, you have a range of different options that will vary down here, but it's explaining right here how, depending upon which option you select here, how EFDC is actually computing the head that goes into the lookup table. So you have a lot of flexibility here. But one of the big things now is that this is the same editor that you've seen before for time series, but for these types of boundary conditions, it has to be a grid because it's an upstream and downstream condition. So this is your upstream head, your downstream head, and your flow lookup in the upstream downstream tables. And then I can plot these up and look at, say, for instance, what do these flow curves look like? So this provides a, looking at, depending upon what the downstream head is, as the downstream head increases, I get more and more submergence and less flow. And so this is just kind of showing what's, the rating curve for that particular structure. Just in this mode, it's more of a QC check. But you can also, go in here and EE will actually compute the flow at a particular time and tell you what the flow is inside of the EFDC. So very robust capability now for handling and managing hydraulic structures.
这个呢，就是那个它这个功能的话，就是我的理解啊，就是那个它这个如何去做一个这个，就是那个如何是做一个它下游上下游，就是它可以选择上下游这个地方，由于是由于这个流量呢是由于什么样的原因产生的？它这个流量是因为上下游的这个位移的那个，就是上游的这个高层之间的这个差产生的呢，还是由于这个上下游有这个来水，上下游would you close it the two windows here? To show how the flow derives.
Oh yeah. Yeah. You mean?
No, not this.
Not this.
This one, close it. Yeah, it's right here. The flow control time, right?
Right. It's controlled by the upstream and downstream elevation.
It means that this grade, the flow in this grade derives from the upstream and downstream elevation, right?
Right. It's whoever developed is managing that structure, designed that structure. You have a rating curve for that structure, and so what we're doing is we're just bringing in that rating curve into the model, and what's coming into it are elevations. So I know my water surface elevation upstream, and I know my water surface elevation downstream. I know my flow based on the rating curve, and a given upstream head, and as the downstream head increases, it begins to submerge the hydraulic structure, and your flows will decrease as your head increases. And those tables can be now put into EFDC and the EFDC Explorer, and you can visualize it and manage it more effectively now.
他说那个这样根据这个就是这个地方，有的时候就是说下游根据上游和下游的这样一个水位的水位的这个高层的这个之差的话呢，它可以EFDC可以判断，因为那个就是说上游的来水，它这个来水的流量它是这么多，然后下游的这个跟上游的流量这个来水，因为下游的这个水位如果高于上游的这个来水的话，下游其实会有一个流量倒灌。这倒灌的话，它 EFDC 就根据这个上下游的流量就水位这样一个高低呢，它会会重新计算一个这样倒灌的这样一个流量。总之，它这是个新的功能。这个功能的话，大家如果有需要的话，可以去那个敬请期待 EFDC Explorer 7.2。
So for instance, even if you had like a series of pipes underneath a major road, and you knew the hydraulic behavior of those, then you can put that table into EFDC, and then EFDC can handle that structure just fine. Okay. And with that there's a lot of details we can play around with. Time series contours are nice to be able to display. That probably wouldn't. Now I don't have the right model loaded, so. But we have this. I'll stick around and keep showing features if you guys want to stick around, but I think we should pretty much call it a quits for the day.
OK， 他包括说他说这个功能要讲的话，今天肯定讲不完。那个咱们这个有一部分的功能的话，我们会留到那个就是明天的话，如果大家有兴趣的话，明天下午也可以再加一部分时间去讲下这个。今天的话呢，我看大家时间就是说也到了，这样的话呢，今天内容的话，老师也累了，我们同学也比较累。 我们要不然这样，那个我们稍作休息一会儿，and we should take a break and have dinner, right? Have you
Well, that's
finished?
right, tonight's group dinner. And
Yeah. Have you finished all the posts today? Have you finished all the tasks today?
We have.
OK 就是那我们就那个结。